So all of the metal additive manufacturing methods discussed here use metal powder. Where does this powder come from and how is it made? There are numerous methods that are used commercially to make metal powder, including atomization, chemical and reduction processes, the carbonyl process, and others. But we're only going to talk about atomization because the vast majority of metal powder used in additive manufacturing is made by atomization. Melt process atomization produce powders at the highest level of economy over a wide range of metals and alloys and produce the qualities needed for most AM processes. Atomization, in general, is the disintegration of a liquid stream into droplets. In the case of metal, the droplets subsequently solidify, becoming the powder particles. I'm going to split atomization into two general categories: bulk melt methods and non-bulk melt methods. For bulk melt methods, the metal or alloys melted in a crucible, which feeds the atomizer. The crucibles range in size from a few pounds or kilograms to many tons, so this method has a wide range of scale and economy. Non-bulk melt methods convert metal from a wire or rod or even other powder to form the melt as needed to feed the atomizer. The two most common bulk melt atomization processes are gas atomization and water atomization. When inert gas is used, the powder particles tend to be spherical, which have the advantage of flowing well and packing well. Water atomization produces more irregularly shaped particles with lower flow and packing characteristics. The powders also tend to have a higher oxygen content due to their reaction with the water. The reason for the particle shape difference is due to the cooling rate, which is related to the heat transfer efficiency of the process. In each process, a droplet is sheared from the melt stream, and this droplet is not necessarily spherical at that time. The surface tension of the liquid drives the droplet to spherize, which minimizes the surface area and thus the surface energy. For gas atomization, once a droplet is sheared from the melt stream, the cooling takes place relatively slowly. The droplet has time to spherize before solidifying. For water atomization, the droplet is sheared from the melt stream, and the quenching power of the water solidifies the droplet before it has time to spherize, thus producing more irregular powder.